everyone. Welcome to the NPTEL course Network Analysis. I am Teja Golla, and these are the problem solving sessions that I'll be taking every week for each of the week of this course. And week one is about introduction to network elements, circuit elements, and sources. Let me share my screen. So I hope you are able to see my screen. Can anyone please confirm? Yes. Okay. So before we go into the technical discussion, I just would like to give some brief introduction about myself, and I'll also give some introduction and brief discussion about what to expect from these sessions, and I'll also provide you the links so that you can access the material. So myself, Teja Golla, a fourth year research scholar working under Dr. Santanu Kapat at Embedded Power Management Lab, Department of Electrical Engineering, IIT Kharagpur. So I'm a PhD student and I'm also a Prime Minister Research Fellow. So I have done my bachelor's from IIT Kharagpur in the year 2021, and then I have converted to uh, PhD. So now I'm currently doing my PhD in control system specialization at IIT Kharagpur under Professor Santanu Kapat. And this is my background. You can access these videos from my YouTube channel, and the link I'll be providing now. And here's the brief introduction about myself. So now going into these problem solving sessions. So there are multiple tiers for each course. You can attend any one of the course, or if you like, you can attend all the sessions as well. So basically what to expect from these sessions, we'll be taking these sessions where we'll be discussing some of the concepts that are covered if you have any queries, and then we'll solve more problems. Then we'll help you understand the concept and apply it to the problem. So we'll solve previous year assignments. I'll be solving 2024 year assignments so that if you have any doubts, it can be cleared. And also this session will help you to understand how to apply the learned concepts in solving the problems so that you can solve last year problem, and this year also you can expect similar type of assignments, so that will help you do better in the assignments. So these sessions will happen on every Monday 6 p.m. to 8 p.m. If I am unavailable, then it will be either preponed or postponed, and the same will be circulated by the NPTEL team at least 2 to 3 days prior. So keep this Zoom link handy so that you can join the entire semester. Whatever sessions that will be happening, they'll happen in the same Zoom meeting. So you can attend if you keep the links with you. And earlier I have done this problem solving session for three different NPTEL courses. So in the 2023 autumn semester, I have done for the course Digital Control in Switch Mode Power Converters and FPGA based prototyping. And the link I have provided here. So these notes also I'll be uploading to my drive, and I'll provide you the links, all the links. And then last year I have done this course, network analysis, whatever you have been registered to this semester. So I have taught all the concepts, relevant concepts, and solved 2023 year assignments, most of the problems. And all the videos are recorded and uploaded to my YouTube channel. So you can also go through those lectures. And again, I am taking this course this semester again. So this time I'll not be solving 2023 assignments. Instead, I'll solve 2024 assignments. So both the year assignments will be there available on the YouTube, and the link to the YouTube playlist I'll be providing to you. And after this, last semester, I have done basic electrical circuits, which is quite similar to network analysis. So if you want to go through that also, you can go through that. And so all these three courses are 12-week courses. So I have taken 2 hours per week, so 24 hours. And then I have taken one hour session before the exam. So if you have any doubts, you can ask. Also, I have summarized whatever I have taught in these 12 weeks in that 1 hour session. So if there is any doubt in the concept, so people can ask in that session. Again, in this semester also, it will happen like this. So we have 12 weeks for this course. Each week I'll take 2 hours, Monday 6 p.m. to 8 p.m. So 24 hours. And then after that, I'll take one summary session where I'll be summarizing all the concepts that were taught, as well as if you have any doubts, I'll address them in that last 1 hour. So coming to this network analysis, the course outline as specified in the website, it is something like this. So the week one is about introduction to network circuit elements and sources. Then we'll go into in detail to energy storing elements, and then we'll also be discussing about how to solve a differential equation, then mesh and nodal analysis with time varying source. Then we'll also see how to get the linear differential equation solution if the excitation is impulse, and also discuss about self and mutual inductance of the coil. Then we'll go into Laplace transform, which will be helpful to solve the circuits easily. Then we'll discuss about network theorems, graph theory, and then how to do circuit analysis with dependent sources. Then we'll move towards two-port network, gyrator, and finally we'll end with the ideal open circuits. So coming to this problem solving session, as I have mentioned, first I'll be revising all the relevant theory that was taught. So first I'll be discussing the relevant theory. Then I'll also solve some solved examples, whatever that are available. I'll be discussing that. So first we'll be covering the relevant theory. Then I'll solve few solved problems so that the concept will be correlated by solving the problem. Then we'll solve the previous year assignments. So this time I'm solving 2024 year assignments. So whatever assignments that were provided by the course instructor Avishek Chatterjee, Professor Avishek Chatterjee last year, we'll be solving that this year. And you can expect a similar problems, but not the same problems. So if your concept is clear and if you are able to solve these previous year assignments, then you can expect to do the same for the current semester problems. So as I have mentioned, every Monday it will happen from 6 p.m. to 8 p.m. Unless specified, it will happen every Monday. If I'm unavailable for some reasons, then either it will be preponed or postponed, and the same meeting, the same information will be mailed to you from the NPTEL support team. And the link to the lecture videos, as I mentioned, all these will be recorded and then it will be uploaded to my YouTube channel. I'll try to upload it on the same day, if not by the next day. So by Tuesday night, you can expect the video to be available on my YouTube channel, but I'll try to do my best to upload it by today night so that you can access from tomorrow morning itself. And then the lecture notes, whatever problems we'll be solving, they will also be uploaded to my Google Drive. And this link also I'll be providing you. So that's the overall discussion or introduction about myself, as well as what to expect and where to find the material and what will be covered in the upcoming 12 problem solving sessions. So any doubts until this point? Any queries, any confusion? Anyone? No. Okay. So I'm sending certain links. So here I have shared my YouTube channel. So you can keep this links where I'll be uploading all the recorded video so you can access them, and link to the Zoom meeting. So this is the current Zoom meeting link that you have entered. So the same Zoom meeting will be used every session throughout the entire semester. So please keep these links with you, and then drive to access the notes. Whatever notes that I'll be making or the problems that I'll be solving will be uploaded to this drive where I'll make folders week wise, and then I'll upload. Because this is the week one, I have not yet uploaded, it is empty, but by tomorrow I'll upload the notes. Then the problem solving sessions that I have taken last year, I have also uploaded to the YouTube, and I have made a playlist. So if you want to access that, you can also access that. I have provided the link here, YouTube link. So you can click that and watch the videos that were recorded last year. And the same we are doing this year, but the problems will be different. And then last year notes, whatever I have made, I have uploaded to the drive. So there also you can access. So if there are some concepts that I may not cover this time, which were covered earlier, then I'll provide the necessary link and the YouTube video as well as the notes. So you can access them from the last year because it's already available online and you can access it at any time. So until this, any doubts? Are you able to access all the links? Everyone? Yes, sir. Okay. So we'll get into today's discussion. So I expect everyone to be interactive because this is more like problem solving session. This is not like teaching one-sided because these problem solving sessions are made to be more interactive with the students, as the professor will not get time to interact. They'll make live sessions and during that time they'll interact. But we are interacting for almost 2 hours every week, which is quite some time. So if you have any doubts, if you have anything to ask, you can use these sessions and fully utilize so that I'll be benefited in teaching you, and you will also be benefited by uh, getting your doubts clarified. So I hope everyone has gone through the week one lectures, and this is something that you should keep in mind, and it is very like important. Don't Yes, I'll resend the links, Akshaya. Just a minute. Yes, I have sent. So do not expect that whatever that was covered in the week will be again retaught in these sessions, and expecting that do not skip watching the lectures. Keep two things in mind: the lectures that sir has taught will be very deep. He will cover the concepts in depth, and these sessions are mainly for problem solving sessions. But knowing that you people will be having doubts, I will also be explaining the concepts, the important concepts in a very subtle way, surface level, not in depth, because covering all the concepts in 2 hours plus solving the problems will not be like it cannot be done in 2 hours. So whatever I have planned last time and whatever I'm planning now, I'll try to take 40 to 45 minutes time, maximum 1 hour, to summarize the concepts that are needed to solve the problems, and then 1 hour we can solve the problem. So we should maximize the time that we are spending on solving the problems, and limit the time for the conceptual understanding little bit, so that we can solve more problems, and then you'll be feeling more confident. But do not join these sessions assuming that everything what was taught by sir will be again taught in these sessions, because this is not the objective of these sessions. Because the recording are already available, you can go through that lectures, but this is only to solve your queries and solve problems. But I'll be quickly summarizing the concepts that are needed, and I hope I have made myself clear. If you have any doubts, you can ask, else we can proceed to today's point of discussion. Any queries until this point? Anyone? Everything is clear? So if you have any queries, you can stop me at any time, and you can unmute yourself and ask the doubts. So shall we start, or do you have any queries? No, sir. Okay. So as the topic says, introduction to network, circuit elements, and sources. This week it is just a basic introduction, and we'll be covering the mesh analysis and the nodal analysis, which I think you might have done in your plus one, plus two, and everyone is aware. But let me just take up two examples and solve uh, two circuits and explain you how to apply the concept. So first we'll start with the mesh analysis. So first of all, what is a mesh? So mesh is not any closed loop. Mesh is a that closed loop within which another loop does not exist. So what we can say is there can be a given circuit, there will be multiple loops, but within a loop, if any other loop does not exist, then that loop is called mesh. So I can say any closed loop within which a mesh does not exist. So let me take a circuit, and then I'll explain what does this sentence mean. So let me quickly draw a circuit that sir has considered. And you can ask me any questions like non-technical. Say if you're facing difficulty, how to improve yourself in the exams. And if you have any other queries, you can reach out to me, and then you can contact me if you have any queries. So this is the circuit. Let this be E1, and let this be E2. Sorry, this was considered as E1. So let this be E2. And these resistors are R1, R2, then R3, then R4, then R5, then R6. So there are multiple loops, as you can see. What do I mean? So this is a loop, right? So this is a closed loop. But if you see within this closed loop, I can find another closed loop here, I mean a small loop, another loop here, another loop here. So what happens? Within one closed loop, I have found uh, another loop. So then the outer loop that I have considered and marked in blue color, that is not a mesh. So I have to consider that loop within which another loop does not exist. Okay, so let me use three different colors to mark the loops. So what are the loops? This is one loop and this is another loop. Sorry, mesh, not loop. These are the loops that I am considering, which are meshes, because within this loop there is no uh, loop, another loop. So we have to consider that smallest loop within which another loop does not exist. So this circuit has three meshes. Is that clear? Any doubts until this point? How to consider mesh? What is a mesh basically? No, sir. So identifying a mesh is important because the mesh that we consider will give us the equations to solve the circuit. If the mesh that you have considered itself is wrong, then you cannot apply whatever we are learning. So, so we have found three meshes. So uh, now let us assume mesh currents. So let it be I1, let this be I2, and let this be I3. So now we have three unknowns. Basically, we have three unknowns, which means we'll get three equations. And we have to solve these three equations. And how are we going to get these three equations? Because there are three meshes, one equation from each mesh. Okay. So now, how are we going to write these three equations? So first of all, each mesh, like we are getting three equations in terms of I1 and I2 and I3. So every equation will be in the form A I1 plus B I2 plus C I3 is equals to D. So now the point is, how are we going to get this A, B, C, D? So there is a shortcut in order to do so. You need not apply KVL in each of the mesh, but instead looking at the circuit, you can tell what are the A, B, C, D values. Say I am dealing with the mesh I1. So say I am dealing with this mesh I1 or mesh M1. So the mesh current is I1. So now the coefficient of I1 is sum of the resistances in this loop, which is R1, R2, R3. So the coefficient of this will be, so let me use a different color. So the first equation, coefficient of I1 is R1 plus R2 plus R3 into I1. Why? Because as I have mentioned, in this mesh, the sum of resistances will be, because it's mesh M1 and it is having a mesh current I1, so the coefficient of I1 will be sum of the resistances in that mesh. Because I1 is the mesh current, the coefficient of I1 will be sum of the resistances, which is R1 plus R2 plus R3. Now, every time you have to fix certain things. Like if you see the mesh currents that I have considered, they are clockwise. So please follow this same convention throughout the course, because sir is considering the same convention and you have to also consider the same convention. Is it wrong to consider counterclockwise? Yes. No, absolutely no. There is nothing wrong. You can actually do that. But if you consider two different conventions, then you will be confused. So it's always better to stick to one convention that the course instructor is following, which will be followed throughout the course. So we can follow the same convention without any confusion. So let us stick to it, but there is nothing wrong if you do it the other way around. So in this circuit, we have three resistors. So R1 plus R2 plus R3 is the coefficient. Now, what will be the coefficient of I2 and I3? I2 and I3 coefficients we can get. How? Because I2 is the current in the mesh M2, like mesh 2. So now the coefficient will be negative of the resistance that is common between mesh M1 and M2. So if you see, mesh M1 and M2 has this thing common, this limb, and this has this limb in common. So now this M1 and M2 has a common resistor of R3, and M1 and M3 has a common resistor of R2. So the coefficients are as follows. The coefficient of I2 will be negative of R3. Why? Because R3 is the coefficient. So minus R3 into I2. Then again plus what is the coefficient? Resistance between that is common in between mesh M1 and mesh M3 R2. So negative of that resistance. Sorry, let us use the same color code so that there will not be any confusion into I3 is equals to, now the RHS will be uh, because LHS is a voltage, RHS needs to be a voltage because then only it is correct dimensionally. So how are we going to get the that voltage? So in any mesh, every time, as I have mentioned, we are going to go in the clockwise direction. So we are going in this clockwise direction, right? So this is the direction that we are traversing through the loop. So now if I start from this point, say if I start from this point and I'm going through and I'm getting out at this point. So what is the potential gain or drop that I have seen? So if you see, I am going from positive terminal to a negative terminal, which means there is a drop in the potential. So when I am traversing through this loop in the clockwise direction, I have seen that there is a drop in the potential, and I am only considering the voltage source, nothing else, because that's how we have to follow to get these equations. So if you consider only the voltage sources in this loop, we are seeing a drop in the potential, which means minus E1. So the term will be minus E1. Okay. Sir, here current goes from positive to negative, then current direction anti-clockwise. Yes. So basically, whatever conventions that we consider, we will stick or we'll fix that the current is always flowing in the clockwise direction. And when we solve the equations, we might get current positive, we might get current negative. Say if the current is positive, it means whatever assumptions that we have made that current is flowing in the clockwise direction is correct. If we are getting current is negative, it means the current is actually flowing in the counterclockwise. But we will not consider counterclockwise at the beginning. We will consider everything clockwise, and then we'll follow the same convention throughout the semester for all the problems, and maybe the current could be positive or it could be negative, as there are only two things: clockwise, anti-clockwise. Plus means clockwise, minus means anti-clockwise. Okay, so now that I have told the equation for first loop M mesh 1, can you tell what will be the equation for mesh 2 M2? So basically what I'm saying is, for this M2, what will be the coefficient of I1? So if I'm going into mesh 2, then I2 coefficient will be sum of the resistances in that mesh, and the rest of the coefficients will be negative of the resistance that is common between the meshes. So if I am going to the mesh M2, so the coefficient of I1 will be negative of the resistance that is common between the mesh M1 and M2. So can someone tell me what will be the that value, I1 coefficient? Okay, so this is the common branch that is between mesh M1 and M2. So now can you tell me what is the negative of the resistance that is in common between M1 and M2? Anyone? You have to answer this question. Maybe it could be right, maybe it could be wrong, but if you don't answer, I'll not know whether you have understood or not. Minus R3, yes. So as R3 is the common resistor, the coefficient will be minus R3 and into I1. So now the coefficient of I2 will be the sum of the resistances in the mesh M2. So let me highlight the mesh M2 for you. So the sum of the resistances in this mesh. So can someone tell me what will be the coefficient then? What will be the coefficient of I2, which will be the sum of the resistances in that. So R1 plus R2 plus R3. Can you just check it is not R1 plus R2 plus R3. It is the mesh M2, which I have highlighted. So someone has mentioned Jnanandar Rao, Akshay also R3 plus R4 plus R5. Absolutely correct. And Jnanandar has mentioned minus R3 into I1 plus R3 plus R4 plus R5 into I2 minus R4 I3 equals to E1. Yes, very good, very good. So the coefficient of I2 will be sum of the resistances, which is R3 plus R4 plus R5. R3, R4, R5 into I2. And what will be the coefficient of I3? Coefficient of I3 will be the negative of that resistance, which is in common between that mesh and this mesh, which is R4. So what will be the value then? Minus R4. Yes, Akshaya, you're good, right? So the coefficient is minus R4 into I3. So now what will be there on the RHS side? RHS side, how we are going to get? We have to see what is the potential gain or drop when we are going traversing that loop in the clockwise direction. So whether I'll see a plus E1 or minus E1, anyone? Plus E1. Gokul, you're right. So it is plus E1. So we are getting plus E1. So we have got two equations from two meshes. Now we have to get the other equation from the third mesh. So Jnanandra Router has already mentioned minus R2 into I1, right? Minus R4 into I2, right? But for I3, it will be R2 plus R4, which you have made a mistake. So let us again see. So now we are in the mesh M3. Say this is the mesh M3. Now I have to get I1 coefficient, I2 coefficient, I3 coefficient. So I1 coefficient will be what? The negative of the resistance that is in common between the mesh M3 and M1. So, uh, so can anyone tell me what will be the coefficient of I1? Anyone? Minus R2. Yes, very good. Minus R2 into I1. And the other coefficients? What is the coefficient of I2? Minus R4, Akshaya. Very good. So the coefficient and Rongala Venkata. Good. Gokul. Yes, minus R4. Yes. Minus R4 into I2. Then what is the coefficient of I3? Summation of the resistances inside that, which is R2 plus R4 plus R6. Very good, Akshay. R2 plus R4 plus R6. R2, R4, R6 into I3. So now what is the voltage expression that I am going to get whenever I traverse in the clockwise direction? So what will be that voltage? Minus E2. Yes, Akshay, good. Ganesh also good, minus E2. So whatever I will be getting, that is minus E2. So these are the three expressions that I have obtained from this circuit, and now I have to solve this. So you know how to solve these equations. So that is not our discussion because it is just linear equations. You can solve. You have to write I3 or I2 or I1 in terms of other, and then reduce it to two variables, and then you can solve. So that is simple math. But as we are discussing the concept, so this is the like overall concept, I hope it is clear, at least the mesh analysis. So looking at the circuit, we have to first identify the meshes, how many meshes are there, and then we have to assign the mesh currents, I1, I2, I3. Then we have to write the equation in each of these meshes. Mesh M1, mesh M2, mesh M3. Say I am dealing with mesh M1, the coefficient of I1 will be summation of the resistances in that mesh, and then the coefficient of I2 and I3 will be negative of the resistance that is in common with mesh M1, M2 as well as mesh M1 and M3. Now coming to the RHS side will be a voltage source, and the value we will get by checking the voltage gain or voltage drop when we are traversing through that particular mesh in the clockwise direction. So these are the things that you should keep in your mind when writing these equations, and you should not make any small mistakes. Say if I make minus and plus and minus, I'll make a mistake, and I'll end up getting a wrong values, which we should not do. So we have to be very careful while writing this. You take time, write it properly, and make no mistakes, because if you make any mistake, then your I1, I2, I3 all will be wrong. So you have to write the equations very carefully, because your entire answer marks, everything is dependent on that. So you should be very, very careful while writing these expressions. And one more thing, the Zoom meeting sessions that I'm conducting now, they are limited to 40 minutes. So what happens is, after 40 minutes, the meeting will end. So once the meeting ends, using the same link, you please join back. I'll also join back, and then we'll continue our discussion. Again, after 40 minutes, it will end. Again, you join back, and then we'll continue the last 40 minutes. So it's a 2-hour session, which is 340 minutes. So after every 40 minutes, the meeting will get stopped automatically. Now we have less than a minute. After this, the meeting will stop, because I don't have the subscription. So please bear with this. I hope it is clear, right? If this meeting end, the link that I have provided, please use that link and join back. I am maybe sending it again. uh, it is clear, right? So please use these links, and then join back. The meeting will be ending in less than a minute. Once everyone joins back, then we can continue. I hope it is clear for everyone. So the meeting is going to end soon. Kindly join back so we can continue our discussion. Someone has asked that out. Let us come back, then I'll address your query. Ganesh, yeah, very good question. What if there is only a current source between mesh 1 and mesh 2? Yes, yes, very good question. Okay, I hope you are able to see my screen. So one person has asked one query. Uh, he said, what if there is a current source between mesh 1 and mesh 2? Very good question. So this is called super mesh. So, so what is a super mesh? So this is a condition in a circuit when two meshes share an ideal current source. I hope I'm audible. Am I audible? Is my audio clear and video also? Hello? Yeah, okay. So what does this mean? So let us use this same figure and slightly change it. So, so now what I'm doing here is, I'll erase this middle portion, okay? And I'm putting a current source, okay? So now what happens is, when these two meshes share an ideal current source, in order to uh, get an equation, we cannot apply KVL in mesh M1, this mesh, and in this mesh also. Why? Because we don't know the voltage across a current source. Then what we are going to do is, we have to apply super mesh, meaning we'll consider the outer mesh. So we'll be considering this outer mesh. So this is called super mesh, because in this mesh, first of all, in this mesh, there are two meshes inside, but we are considering this mesh because inside that small mesh, meaning this mesh, and this mesh, we cannot apply KVL because I don't know the voltage across the current source. So now what I am going to do is I am combining these two meshes. Those two meshes which are sharing an ideal current source, I am combining those two meshes and then considering the outer mesh. So this is not applicable to any two random meshes. This is applicable only when you are having a common current source between those two meshes. And once you combine the both the meshes and consider that mesh outside, then this is called super mesh. So the idea is I have three equations. Sorry, I have three unknowns, which means I have to get three equations. Earlier, what happened? Earlier, I got each equation from the each mesh, but now I cannot get each equation from each mesh because I can neither apply KVL in mesh 1 nor I can apply KVL in mesh 2. So I am less of two equations. So first of all, what are the equations? So first I can apply KVL in mesh M3. Okay. And then I cannot apply KVL in mesh M2. I cannot apply KVL in mesh M1. So how are we going to get the next two equations? So first of all, let us give this, say, some current I naught. Now I know I1 minus I2 is equals to I naught by applying KCL. So by applying KCL, we can get one equation. In this, I cannot, maybe I should not also directly say KCL because it is not applicable to any node. But if you see, current I1 is flowing in this direction, okay? And the current I2 is basically flowing in this direction. So I1 minus I2 is equals to I naught. So I am getting one equation from the current source, okay? And what is it? I1 minus I2 equals to I naught. Okay. So now I got the second equation, sorry. Now from where will I get the third equation? The third equation I will be getting by applying KVL in the super mesh. And what is called the super mesh? The mesh that we consider the outer mesh when the two meshes sharing a ideal current source is combined. So this is how we get the three equations. And this is called super mesh. So we'll apply KVL in that mesh where there is no current source, and we'll apply uh, KVL in the super mesh that will give us two equations, and the third equation will directly get from the current source because this mesh is having I1, that mesh is having I2. So the shared current source should have the current which is subtracted from that mesh current and this mesh current, and you should be very careful with the direction because I0 is flowing down, I1 is more than I2 because current is flowing down. So the direction is very crucial. One should not make any mistake while writing that expression. If the current I naught is flowing from bottom to top, then it will be I2 minus I1 equals to I naught. So is this clear to everyone? Why I2 minus I1? Yes. What I was trying to say is, say if the current I naught is from bottom to top, say I naught is in this direction, but we already have I1 flowing down and I2 flowing up. So if you consider KCL, I1 current flowing down is equals to current flowing, sorry, not KCL. So I1 is flowing down and I2 is flowing up. So the net current that is flowing up is what? I2 minus I1. So net current that is flowing up, I2 minus I1 should be equal to I naught. So that's how we are getting this. Is that clear? Whoever has asked? Yes, sir, clear. Okay. Yes, sir, clear. Okay. So now that we have completed the mesh analysis, let us just solve a quick example. Okay, I think someone is waiting. Yeah, let me do it. If the current source also has a resistor connected to it, yes, that is also a very good question. Then it will be a little bit more complicated. But as far as this course syllabus is not, as far as this course syllabus is considered, we'll not have another resistor there. If you have another resistor there, it will be a little bit complicated. But that is outside of the this course syllabus, so that problems will not be given in the exam. but very good question. Okay, so let us solve one problem from the mesh analysis that sir has considered. So let me draw the circuit. So you should be solving before me. It's not that I will tell you how to solve, but it should be the other way around. You should solve quicker and you should tell me that we have to solve this problem like this. And not just someone, everyone should be trying, putting in the same efforts and do. You can make mistakes, but you should try. Okay, first we'll start with a simple question, then we'll go to a complicated question. So this is the question. Now let me give the values. So this is 2 ohm, this is 10 volt. First of all, tell me how many meshes are there? Two. Yes, very good. Two meshes are there. Sir, can you just explain that in the last of the session if possible? Yes, Gyarendra, I'll explain you. You just remind me again. Towards the session, I'll explain you. So basically, all these questions, like you can see my screen, right? Hello. But why is my video? Okay. Okay. You can see my screen, right? Yes. Okay. So there are two meshes as everyone has pointed out. So this is the mesh M1. This is the mesh M2. So now I'm considering I1 and I2. So that makes this mesh M1 and this mesh M2. So now I'll ask you. So if you write the equation in mesh M1, what are the coefficients? So what is the coefficient of I1? So first of all, I'm writing in mesh M1. Then I'll write the equation in mesh M2. So what will be the coefficient of I1 and what will be the coefficient of I2? Yes, sir. 5. Jnanendra Singh says 5. Everyone agrees with him? 5 and minus 3 is what he's saying. So everyone agrees with him, or if you want to change, you can tell. Minus 3 into I1. Ganesh Nair says minus 3 I1. Okay, others? Deepali Wag says yes. Varun says 5 I1 minus 3 I2 equals to 10 minus 5. Any other anyone else wants to tell or say minus 15 E2? Someone says minus 15 E2. There is no E2, Gokul. Minus 15 E1. What is E1? There is no E1. Shivam Kumar says agreed. So as we are writing the equation in mesh M1, I1 coefficient will be summation of the resistors in the mesh M1. So what are the resistors in mesh M1? 2 and 3. So it will be again positive because it's inside that. So the value will be 5. Many people have said. And I2 coefficient will be negative of the resistance that is in common. So this is the 3. So we'll have minus 3. And what we'll be getting on the other side? Some voltage, which we are getting by traversing through this loop in the clockwise direction. So it is plus 10 and minus 5. So it is 10 minus 5. 5 volt. Yes, many people have said 5. Yes. So we have 10 minus 5, which is equivalent to 5. Now let us do the same in the mesh M2 and let me tell what is the let me know what is the coefficient of I1, what is the coefficient of I2, and what is the RHS side value. So someone says minus 3 I1 plus 7 I2 equals to 3, Akshaya, and Gokul says minus 3. Yes, it is right because I1 and I2 are sharing a resistance of 3 ohms, so it will be minus 3. And Gokul says 7. So first one will be minus 3 because the resistance that is shared is 3, and then the other one will be summation of the resistances in this mesh, which is 3 plus 4, 7. Very good. So we have here 782. And then the voltage source will be what? 5 minus 2. Yes. Varun and Gokul. Yes, it is 5 minus 2, which is 3, because we are going in the traversing in the clockwise direction, which is 5 minus 2. That is equals to 3. So now I have two equations, and I also have two unknowns. So can you solve and tell me what is the value of I1 and what is the value of I2? So this is a simple part. So I'll just ask you to do. So let me know what is the value of I1 and what is the value of I2. I have already solved before, so I have the answer. You just calculate and let me know. And don't make mistakes. Take your time. But tell me what is the value of I1 and what is the value of I2. I'm not exactly sure calculator whether they'll provide or not. But since this is a two variable equation, I think you can solve by hand. So 4.38 and 2.3. This is what Jnanendra Singh is saying. Let us see what others says, and let us check if everyone is getting the same answer. You also cross check, see if you have made any mistakes. So mesh analysis and nodal analysis both are equally important. Uh, okay, someone says 1.69 and 1.15, Shivam Kumar. Okay, if others are trying, please try. So when I was in BTech, I always used to have a little bit bias for nodal analysis because I was always more comfortable with nodal analysis. So I always used to think that any problem can be solved using mesh analysis and nodal analysis. So why should I learn mesh analysis? Instead, I could solve all the questions using nodal analysis, but it is not actually always correct. There are few problems where mesh analysis will be easier, meaning we'll solve the equation in lesser number of equations, whereas applying nodal analysis could be difficult. Similarly, there can be some circuits where applying nodal analysis will get you to the answer in a faster way or a simpler way than mesh analysis. So both the methods are equally important. Although you can solve any problem using mesh analysis as well as nodal analysis, it's not that I'll always will always apply mesh analysis or will always apply nodal analysis. I did that mistake, so don't do it. Learn both the methods, because it's a competitive exam where time is a constraint and you have to get to the answer in a lesser time. So sometimes you have to apply mesh analysis, sometimes you have to apply nodal analysis. So if you see in the case of super mesh, directly I'm getting one equation just looking at the circuit, and you have to get two more equations. Say if this current source is outside, then we can directly get the one of the mesh equation, whereas in that case applying nodal analysis you will get more equations. So depending upon the circuit, sometimes we can choose mesh or nodal analysis and you can solve. So most of the people says 1.6 and 1.15, Gokul, Jnanendra and Shivam. Yes, so I think Jnanendra has made a mistake and rectified. Yes, so if everyone has solved, you will be getting this I1 as 1.1, sorry, 692 amperes, and I2 as 1.153. So this is the answers that you will be getting. Okay. So I hope everyone will be able to do. So if you have any questions until this point, you can ask, because now we are going to learn about the nodal analysis. So any queries until this point? Anyone? No, sir. Okay. No, sir. Okay. So now, sorry, what is this? Okay. So let us go to the nodal analysis. So let us consider the same circuit that we have considered for this, but instead of considering the mesh currents, we'll consider node voltages. So if you see everything for mesh, it is current, and for node, it is voltage. So here we'll not be considering any. current. So for nodal analysis, okay, let me put the heading nodal analysis. Okay, so very first thing that we should do is we have to put a reference. So reference can be put at any point of the circuit unless specified. So in some of the problems they'll specify that this is the ground. You must take that terminal as the ground, else you'll get wrong. Else you'll make a mistake. So if there is no ground specified, then you are free to choose any terminal as ground. Consider that terminal to be ground which has more branches connected, because that will make your life simpler. But here all the nodes has three branches connected. You are free to choose any node to be ground. Say this is what I'm considering ground. So now I'll consider this as node A, node B, and node C. Say ground, I'm calling it as point O. So in the case of mesh analysis, my unknowns are what? My unknowns are currents, because I'm trying to calculate the mesh currents. So let me use the same thing so that you can directly correlate. So again, first of all, uh, what is a node? What is a node? Node is an intersection of two or more branches. So if there are three branches, four branches intersecting at a point, that point is called a node. So here we have four nodes. One node we have declared as ground. So instead of meshes, what are we going to have here? So instead of meshes, three equations, three meshes we will not have. Instead of meshes, we will apply at the nodes. So how our equation is going to change? So instead of I1, I'll just cross it and write on top so that you will understand what are the changes. So instead of I1, I2, I3, we have VAO, VBO, VCO. Because in the mesh analysis, mesh currents are the unknowns. In the nodal analysis, node voltages are the unknowns. So in the case of current, current will be multiplied by resistance to get voltage. Now voltage will be divided by resistance to get current. So here A and B, C are inverse of resistance and D is current. Whereas in the case of mesh analysis, A, B, C are resistances and D is voltage. So maybe it is better if I write. So we have mesh analysis. What are A, B, C and what is D? And then in nodal analysis, what are A, B, C? Because it should be correct dimensionally. So here it is resistance and here it is voltage. Here it is 1 by resistance and here it is current. So uh, it is just the same thing, but one should know what is the difference so that they can understand it better. Sir, using node we can only solve for voltage. Yes, Gokul, using node we can only solve for voltage. But say if someone is asking what is the current that is flowing through R2, now I know the potential difference across the R2 as well as the resistance R2. So I can calculate the current. Likewise, if I know what is the current that is flowing through all these terminal, all these elements, I can also calculate the node voltages. So suppose in a question they are asking currents or voltages, you have to see whether applying the nodal analysis makes your life simpler or easier, or applying the mesh analysis or nodal analysis. You have to make a choice unless specified. Most of the problems they'll specify that use this, use that. If they're specifying, you have to use that. If they do not specify, you have to check whether mesh analysis is easier or nodal analysis is easier. In the circuit, neither of them will give you any benefit. Both are mostly same. Then you can select which one you are comfortable with. I am always comfortable with nodal analysis, so I might prefer nodal analysis. But if I see that mesh analysis will reduce the number of unknowns and as well as equations, then I'll prefer mesh analysis. Is that clear? Okay. So now again here we have to get three equations: VAO, VBO, and VCO. So in the case of mesh analysis, we are applying in a mesh. In the case of nodal analysis, we'll apply at a node. So we'll start with node A, then we'll go to node B, and we'll go to node C. So at node A, the coefficient of VAO will be summation of inverse of the resistances that are connected to that node A. So what are the resistances that are connected? The resistances that are connected are R1, R2, and R6. So the summation of inverse of those resistances. So we'll get 1 by R1 plus 1 by R2 plus 1 by R6 into VAO. Then for VBO, the same thing, negative of the resistance that is connected in between the nodes. In the case of mesh, it is the resistance that is being shared between the meshes. But in the case of nodes, it is the resistance that is connected in between the nodes. So because resistance can be connected between the nodes and it can be shared among meshes. So the terminology might be different, but you should understand the uh, this philosophy. So resistance R2 is connected between A and B because we are writing the coefficient of VBO. So it will be minus 1 by R2. So minus 1 by R2, sorry, into VBO. Then for VCO, what is the resistance that is connected in between A and C? R6. So it will be minus 1 by R6. Minus 1 by R6 into VCO. Now what comes on the RHS side, as I have mentioned, current will come on the RHS side. So now you should see what is the current that is coming from the voltage source that is connected to the terminal A. So terminal A is only connected to E2, right? Terminal. So in this branch, there is no voltage source. In this branch, there is no voltage source. So now what you have to do is first identify what are the voltage sources that are connected to that particular terminal. After that, say here E2 is connected. So now the value of the current will be the voltage in that branch by the resistance in that branch. So it is basically E2 by R6. So E2 by R6. Because E2 is connected and it has a resistance R6. Whether it is plus or minus, you have to see which terminal is facing towards the point A. Positive terminal is towards the point A, so it is plus. If the E2 is the other way around, it will be minus E2 by R6. Once again, sir. Okay. I'll explain the equation from the very beginning. So the nodal analysis will be applied at a node. So VAO will have summation of the inverse of the resistances that are connected to the terminal or node A. Now, if we are going to the other terms, VBO and VCO, it will be negative of the resistance that is in between those two nodes. Between A and B, resistance is R2. So it will have minus 1 by R2. Similarly, for VCO, it is a minus 1 by R6 because R6 is shared between A and C. Now coming to the RHS side, which is somewhat tricky compared to mesh analysis, you have to see which branches that are connected to the terminal A has voltage source. So only E2 and R6 is the branch that is having the voltage source. So now what you will write is first E2 by R6. So that is the current value in that branch. So now in order to define whether the current is positive or negative, you have to see whether A is at a higher potential or lower potential in that branch. If you see in this branch, E2, this is plus and this is minus. So A is at a higher potential, which means the sign is plus. Simple, understood? Any queries? If you have query, please ask. I can explain again, but the concept should be very clear. No, sir. So no means you have not understood or I need not explain. Is it clear or is it not clear? Clear, sir. Okay. Others, what about others? Or we'll write another equation, then it will be more clear. So now let us write the equation at VB. So for VB, what is the coefficient of VAO? The negative of the resistance that is connected between A and B. So anyone, what will be the term? You can unmute yourself, or you can also write in the chat box. R2. So it will be minus 1 by R2, Ganesh, because it is negative of the resistance and it is also inverted. So we have minus 1 by R2 into VAO. And what will be the coefficient of VBO? Summation of the resistances that are connected to the node B. So anyone, what are the resistances that are connected?
1 by R2, 1 by R4, and 1 by R3.
Yes, yes, very good. So R2, R4, and R3 are connected. So we have 1 by R2, 1 by R3, 1 by R4 into VBO plus minus now VCO. VCO is the negative of the resistance that is connected between B and C. So what is the value? Anyone?
1 by R4.
1 by R3, R4, right? B and C. So this is the,
R4.
yes, R4. So minus 1 by R4 into VCO. So now coming back to the RHS side, which is a little bit tricky. First, we have to identify how many branches that are connected to the node B has a voltage source. How many branches has? E1 by R3, Gokul, yes, very good. So only E1 R3 are connected. So the current is E1 by R3 and B is at a higher potential. So E1 by R3, very simple. Now going back to the last expression, which is applying the KCL, applying the nodal analysis at node C. So first of all, what will be the coefficient of VAO? Then what will be the coefficient of VBO? Anyone?
Minus 1 by R6.
Okay. And VBO?
Minus 1 by R4.
Okay, very good. And then VCO?
1 by R5.
It's the summation of all the
1 by
resistances.
R6 plus 1 by R4 plus 1 by R5.
Yes, yes, very good. So summation of the three resistors. So let me write minus 1 by R6 into VAO plus minus 1 by R4 into VBO plus 1 by R4 plus 1 by R5 plus 1 by R6 into VCO. Now, what will be the RHS term? So, how many voltage sources are connected to the C terminal? Only one branch. So,
Minus C2.
yes, minus E2 by R6 because it's at a lower potential. Very good. Gokul also said the same, minus E2 by R6. So, from here, we are getting three equations, three unknowns, and simple. So, is this clear? Although it might look a little bit tricky, the more you practice, the more comfortable you will feel. Any questions until this point? Anyone?
No, sir.
Okay, so now we'll quickly go into something called super node. So similar to super mesh, there is super node. So when do we have to apply this? Similar to super mesh, when the super mesh happens, when there is a current source that is shared between two meshes. So when the supernode happens, something exactly opposite. When there is an ideal voltage source between two nodes. So this happens when there is an ideal voltage source between two nodes. Okay. So let us consider an ideal voltage source. So now what happens is again the same issue. I cannot maybe I'll write say some voltage E0. So the point is simple. Let us just go back and correlate. So we have three equations. We have three unknowns. So similar to uh, the mesh, we have now nodes over here. So how we are going to do? So instead of KVL, we have KCL. So now I can apply KCL at node 3 at C, node C. Then in from the current source, we got an equation. Here from the voltage source, we'll get the equation. So from the voltage source, you'll get an equation. What equation you'll be getting? I'll get V1 minus VAO, VA minus VB equal to E naught, right? Because A is at a higher potential. So I got. Clear?
Yes.
Yes. So now what happens? KVL in super mesh, right? Now KCL in super node. So KCL in super node. So in super mesh, what we have considered? We have considered two meshes and consider the outer mesh. So now what we are going to do here, we'll consider this entire node as a single node. And what we will do, current entering the nodes will be current leaving the nodes. So say current entering here and current leaving here. So we'll consider the entire whole thing. So both the nodes we'll consider as a single node, combining both the nodes, and then we'll apply KCL for both the nodes together. The problems will be coming in the upcoming week where there are questions on supermesh and supernode, but for today, I don't think it is covered. Let us see few problems, and if it is there, we'll solve. But this is the information that I'm giving, but it will also come again in the upcoming weeks where we'll solve using supernode. So someone has asked how to get the second condition. So second condition, if you see VA and VB, the potential difference between VA minus VB is E naught because E naught is an ideal voltage source that is given. So E naught is nothing but VA minus VB. Agreed? Right, because the potential difference across that voltage source is nothing but VA minus VB. VA is at a higher potential, so VA minus VB is nothing but E naught. Google, is that clear? Yes, sir. Okay. So any queries until this point? Anyone? Hello. No, sir. Okay. So if you have any queries, please stop and ask me, else we can proceed to solve the same problem. But instead of using the mesh analysis, we can solve using nodal analysis. So first of all, this is not there, this is not there, this is also not there. Okay. Now, let this be ground. So how many nodes exist now other than this ground node? Say this is O.
Three.
One. Yes, Ganesh, you are right. So uh, say if this is grounded, say O, only this is there, A. right? Agree? Agree? Yes. So now how to proceed? So what will be the coefficient of VAO? Anyone?
VAO is 5-1.
So VAO, there is only one, right? And we are applying the mesh analysis at that node only. So what will be the coefficient of VAO? Summation of the inverse of the resistances, right? Hello. Yes. So what is the summation of the inverses of the resistances? Yes. So what will be the summation of the inverse of the resistances? Less than a minute is there, so the meeting will end again because we have completed the second 40 minutes. If this meeting ends, please join back. So what is the coefficient then? So summation of the resistances, right? So what will be the summation of the resistances? Anyone? No one is answering. 1.083. Okay. So if you tell in terms of resistance, it will be half plus 1 by 3 plus 1 by 4. Just check what will be the value of that into VAO is equals to what will be on the RHS side? uh, voltage by resistance plus voltage by resistance of all the three branches. If you see here, we have three equations. I mean, three branches. Each of them have the this voltage, ideal voltage source as well as resistance. So how it will be? So we have to write the current that is in the other branch, this branch, and like branch 1, branch 2, and branch 3. Again, we'll have three expressions. So can you tell me what will be the expression on the RHS side? Anyone?
Double two.
Sorry. Like individually tell the expression so that it will be clear for everyone. 10 by 2, 3 by 17. Shivam Kumar is saying 3 by 17. I'm not sure. Okay. 10 by 2 plus
5 by 3.
2 by 4 plus 5 by 3, right? Agree? And all are plus because A is at the connected to the positive terminal. So now can someone calculate and tell me what is the VAO voltage? I have not calculated, so please cross check and let me know what is VAO. So has anyone calculated? Okay, take your time and calculate. And because I have not calculated, just make sure that you don't make mistake. And let us hope all of our answers match. Okay, someone has said 6.6617. Someone has said 5.846. Okay, now I'm confused which value to choose. Okay, let us see. Uh, if others have solved, then I'll go with the majority of the answer. 6.615. Okay, matching with the Shivam and Indu. Akshay, can you cross check if you have made any mistake? Yes, sir. Okay, so answer is 6.615. Just give me confirmation so that we can proceed. So Akshay, can you just cross check and let me know if the answer is 6.615? 5.8. Gokul is saying again 5.8. Okay, so we have 6.6 and Akshay 5.8. So Deepal is also saying 6.6. So let us assume that 6.6 is correct and let us cross check and tell you how to cross check. So let us say that 6.6 volt is correct. I'm going with the majority. So now, irrespective of the method that you choose, we should get the same answer. Previously, we have solved the same problem using the mesh analysis. So now, in this problem, say I want to calculate this voltage, say VA, and say this is ground. Now I know current I1 is flowing here. So I can write that VA with respect to O is nothing but plus 10 minus 2 into I1. So it is 10 minus 2 into 1.692. So can someone calculate and tell me what is this value? 10 minus 4, 2 9s 18, 1, 2 6 12, 13, 1, 2 1s 3.3. So it is basically 6.616 volt, right? If I'm not wrong. VAO 6.6. Yeah, Gyan and Nixon has told 6.6. So if you see, both should give the same result and both are giving the same result. But if you see in this case, when I apply mesh analysis, I had to solve two equations. Whereas if I see nodal analysis, one equation. Why? Because there are two meshes, but there is only single node because the other node is a reference node. So you can see because here you need to solve two equations. Here I can only solve one equation. So once I get AO, say if someone is asking I1, I can calculate 10 minus VA by 2. If someone is asking I2, I can write VA minus 2 by 4. So you can cross check I1 and I2. So basically, I1 is nothing but the current that is flowing here and I2 is nothing but the current that is flowing here. So I can calculate VAO and from there I can calculate I1 and I2. So like both the methods has their own advantage. So in this problem, maybe we could choose this, what do you say, nodal analysis to solve because only one equation needs to be solved. So is that clear, this problem or any queries? Anyone? Sir, can you please explain how to find number of nodes? Yes. So actually, if you see, as I have mentioned, intersection of sorry, not two or more, three or more. I'm sorry. So every time there should be at least three or more branches, or maybe I could say yeah, three or more because two is so. If you see here, uh, this is one branch. So let me use a light color. So this is one branch. This is another branch, and this is another branch. So if you see three or more branches, so at least three or more, where are they connected? One, it is at A and another, it is at O, right? So three or more branches, if they're connected, then it is a node. So we have two nodes and out of them, one is reference. So basically we have only one unknown node because one node is at already at 0. So one node is the unknown here, whereas in the case of mesh, two unknowns are there. So that's how uh, we have to solve. Sir, how to solve for voltage using mesh and how to solve for current using node? Gopal, very good question. So as I have said here, if I have to calculate I1 and I2, how will I calculate? So here, I1 is nothing but 10 minus VA by 2 ohm and I2 is nothing but 4 minus, sorry, VA minus 2 volt by 4 ohm. So now we can get the currents. Similarly, see how we have calculated this voltage. How we have calculated by applying KVL. So applying KVL here, I got this VA. Similarly, I can go from this side also. It will be 2 plus 4 into I2. So both will give VA. So we have to identify the current. So mesh current is I1, meaning in the 2 ohm, I1 is flowing. In the 4 ohm, I2 is flowing. Whereas in the case of 3 ohm, from top to bottom, I1 minus I2 is flowing. So we have to, if you get the currents, then you know the currents in the elements. From that, you can calculate voltage. If you know the node voltages, then you know the voltage across elements, then you can find the current through them by applying Ohm's law. Simple. Is that clear or any other further queries? Any queries before we solve the actual previous year? Okay. So now let us go to the previous year problems and see. So So this is the assignment one from the previous year. So they're asking V1, V2, and they have explicitly mentioned mesh analysis. Okay. So let us do. So this will be our problem 3. Okay. So this will be our problem 3. So first of all, identify how many meshes are there. For Ganesh says 4. Others agree. Anyone? Yes. Yes. So say this is I1 and this is I2. This is I3. This is I4. So irrespective of the mesh analysis, nodal analysis, the basic philosophy is how many equations are there, how many unknowns are there. So basically how many unknowns are there, how many equations we should get. So here if you see there are 4 unknowns, so I need to get 4 equations. And if you see this current source is being shared, so it is again you cannot apply direct mesh analysis because we don't know the voltage source. I mean, so the voltage across it. So first, can anyone tell me what is the value of I1? What is the value of I1?
1A.
1 ampere. Yes, very good. So I directly got the value of I1 because it is directly given. So I1 is 1 ampere. Okay. Now, can anyone tell me what is the relation between I3 and I4?
4 I3 minus I4 equal to 4A.
Yes, very good. I3 minus I4 equal to 4 ampere. Okay. So I got 2 equations already. Now I have to get 2 more equations because there are 4 unknowns. As no current is being shared with the mesh M2, I can apply mesh analysis for this mesh M2, right? So for this mesh, I can apply mesh analysis, right? So what will be the coefficient of I1? Coefficient of I1 is the negative of the resistance that is shared between mesh M1 and M2. And coefficient of I2 will be summation of all the resistances, right? You remember? Or you forgot? How to get the equation for mesh M2? No one? Hello?
18 dB.
Eh, So the coefficients are I1, I2, I3, I4 are the variables. So
Sorry,
you have to tell
sorry,
me.
sorry. 18. 18 I.
Okay. 18 I2. What is the coefficient of I1?
minus 5.
Okay. And what is the coefficient of I4?
-5.
Okay, what is the
Minus.
coefficient of I3?
No coefficient.
Yes, because the resistance that is common is 0. Very good, very good. So let me write that. So coefficient of I1 is -5 into I1, and then coefficient of I2 is 5 plus 5 plus 8, so that everyone will understand how we are getting this. Coefficient of I2 and coefficient of I3 is 0, so I'm removing that term, and coefficient of I4 is -5 as you have specified. What will be there on the RHS side? A voltage source, right? Voltage source, voltage drop that we are getting when we are traversing through that mesh M2 in the clockwise direction. So in this direction, so what is the term? 0. Gokul, very good, because there is no voltage source. So we'll get is equals to 0. So now I got 3 equations and 4 unknowns. So now I have to get the other equation. One way is, as I have said, super mesh, combining those two meshes and then calculating. Or you can get any other, or you can take any other mesh also. Like, it is up to us. So like, there is no harm in considering any mesh, like any different mesh. So let us see. Because I3 and I4 are having this common shared this current source. So now what I can do is I can consider this super mesh like this. Okay. So I will apply KVL or KCL in this super mesh. First of all, let me make some things very clear. So here number of equations depend number of unknown, that is current. I'm not clear what you are asking, Gokul. Here number of equations depend on unknown, that is current. I'm not sure what you are trying to say. So we have here basically 4 unknowns. So we have to calculate these 4 unknowns using 4 equations, because we are in less equations because of this shared current source. What we are trying to do is we are trying to take the outer mesh by ignoring this, and then we are applying the KVL say. So the current flowing in this resistance is I2 minus I4. Agree? Any query? Agree, everyone. Here number of unknown are current or voltage. Yes, the number of unknowns are currents, because it is mesh analysis. The number of unknowns are 4. They are asking what is the voltage. That's the question they are asking in the problem. But because we are using mesh analysis, always the unknowns are mesh currents. If you are applying nodal analysis, always the unknowns are nodal node voltages. Once you calculate node voltages, what they have asked in the question, that's a different thing. They can ask voltage here, current there, power here, power there. That's a completely different thing. But in order to solve the circuit, the very basic thing, minimum unknowns that I should know is these 4 mesh currents. Once I know this, then I can calculate current in any resistant, any element, or also voltage across any element. So now let us apply the KVL, and let us start from this point and then traverse in the clockwise direction. So what I'll be getting is, I'll be getting something like this. First, plus 10. Super mesh is a combination of 2 or more meshes. So super mesh is the mesh, the outer mesh of these 2 meshes which are sharing this common current source. So here I3, M3 and M4 are sharing this common current source. So now I have combined both the meshes, and I have considered the outer part, so that there is no current source in that mesh, which I have highlighted here in the blue color. So these 2 meshes I have combined to make it super mesh. Now I will apply KVL in this super mesh. So I will start at this point that I have mentioned, and I will traverse through this mesh in the clockwise direction. So plus 10, then plus 5 into I2 minus I4 plus 20. And what is the current that is flowing in this? I3. So minus 2 I3 is equals to 0. Is this clear, or any question or any doubt? Anyone? I hope this is clear, or you have any doubts? Clear. Okay. So now if you see, what are the equations that we have? This is equation 1, which is already
Sir,
known.
I4 minus I2 should come, no, sir.
Okay, I'll come back. So 3, then 4. Okay, so I have considered the current from top to bottom, that is coming from this point to this point, which is I2 minus I4, right? Because the current is flowing down. Agree? I2 minus I4, because I2 is flowing from top to
Clockwise.
bottom. Yes, I2 is flowing. So if you see, I2 is flowing in this direction and I4 is flowing in this direction. So if I am considering from top to bottom, I2 is having more magnitude. So I2 minus I4, because I have considered the direction to be like that. Clear or not clear? Did you get it? Whoever was asking. Should I explain again? So I2 is flowing in the clockwise direction. So in this element 5 ohm, the current is flowing in the down direction, and I4 is flowing in the clockwise direction, which means in this 5 ohm, I4 is flowing from bottom to top. So now I have considered the current that is coming from top to bottom. So I2 minus I4, because as the current is flowing from top to bottom, there are two components. One is I2 component, which is flowing from top to bottom, and then there is I4 component, which is flowing from bottom to top, which is uh, I4. So I2 should be more because I have considered the direction to be from top to bottom. Okay. Is that clear, or whoever has asked? Equation 4. So Gokul is asking how to get equation 4. So I have started at this point. So I have started at this point, which is my reference point. And then I have gone in this loop in the clockwise direction. So what am I getting? I am getting plus 10 because I'm increasing the potential. I'm going to higher potential. Then I have reached this point. Now I am again going to a higher potential, which is plus 5 into I2 minus I4. Then I have reached this point. Then I haven't, again I have reached this point, which is at a higher potential. So plus 20. Now from this to this, I'm reaching a lower potential because current is flowing from this point to this point. So minus 2I3. Sir, how to get equation 3? Bhupendra Goyal. So equation 3, how we are getting, because we have discussed how to get the mesh analysis equation in a given mesh. So in this mesh I2, the coefficient of I1 is negative of the resistance that is in common between mesh M1 and mesh M2, which is 5, so minus 5. And the coefficient of I2 is summation of the resistances in that mesh, which is 5 plus 8 plus 5, 18. And then coefficient of I4 is negative of the resistance that is shared between mesh M2 and mesh M4, which is minus 5. And on the RHS side, we'll get the voltage drop in this mesh M2 when we are traversing in the clockwise direction. But there is no voltage source in this loop, so that's why we are getting 0. So is this clear, or any further doubts?
In equation 4, minus 5 should come, no, sir.
Okay. So you have understood I2 minus I4, right? I2 minus I4, you understood, right? This until this point, how we are getting I2 minus I4.
I2 minus I4 means it is in
Yes.
anti-clockwise direction.
Yes, so I2 minus I4 is from top to bottom. So now if you see this terminal is X and this terminal is Y. Y is at a higher potential or X is at a higher potential?
Y.
Y. So now when I'm going from X to Y, I will gain potential, right? So plus 5 into the current that is flowing. Got it? Similarly, if you
You're
see,
taking reference to V2.
sorry, can you repeat it again?
Y is higher potential because with reference to V2 also.
No. I have assumed that the current is flowing from top to bottom. I have assumed that I2 is greater than I4, so current is flowing from top to bottom, which means Y is at a higher potential. If you assume I4 to be greater than I2, then you will get X as a higher potential, but still you will get the same answer because my sign is my sign is related to the convention that I have taken. So if I2 is greater than I4, I will get plus 5 into I2 minus I4. If I consider I4 to be greater, then I will get minus 5 into I4 minus I2. So both will give me the same result. You can check. You can write the expression and see both will give the same. So Gokul, in the equation 4, we have not used mesh concept. No, we have not used mesh concept. Instead, actually, you can use the mesh concept, but it will be little bit like what I would say, not so straightforward. So that's why I have directly written the KVL. Because it would be easy to consider in this way. That will be more. Sir, Gokul, we are considering clockwise, so I4 minus I2. See, I can see, first of all, okay, let me come back to this point. So, uh, this is the resistance, right? 5 ohm. So now, if I ask, what is this current that is flowing in the 5 ohm resistor? So, what is the value of this in terms of I2 and I4?
I2 minus I4.
I2 minus I4. Okay. Say this potential is Y, this potential is X. So now what is the value of V by X? What is the value of V by X? Using Ohm's law?
I2 minus I4 into 5.
Yes. 5 into I2 minus I4. Okay. So now let me consider the same thing, but in a different way. 5 ohm. So let us consider that current is flowing in this direction from bottom to top. So what is the value of current then?
5
What?
into
No, value of current.
I4 minus I2
Value of current.
current.
I4 minus I2.
I4 minus I2. So now, which is at a higher potential, Y or X?
X.
X. So X should be positive, right? So Vxy is what? Vxy is what?
5 into
5
5
into.
into I4 minus I2.
Okay. Now what is V by X? 5 into.
Minus 5 into I4 minus I2.
Okay, which is also can be written like this. So now if you see, both are same, right? And both will be same. So now what I have done, I am going from X to Y. So I am going from point X to point Y. So I am going to a higher potential. So here 5 into I2 minus I4, here 5 into I2 minus I4. Irrespective of your assumption, the expression will remain same. Because here, if you consider that this is at a higher potential, then you are getting I2 minus I4. If you are considering this is at a higher potential, you are getting I4 minus I2. But as an expression, both will remain same. So irrespective of any assumption you take, the expression will remain same. But here I have made one assumption and I have proceeded with that. Got it? Now is it clear? or still you have some confusion? Yes, okay. So now let us not go and waste our time in solving. I have solved it, so I will give I1, I2, I3, I4 values. So if you solve, these are the values that you will be getting. So I1 is already known, 1 ampere, and I2 is 1.435 ampere, and then I3 is 8.168 ampere, and I4 is 4.168 ampere. Fine. So you can cross check later because we are running out of time, and this is just a mathematical calculation using these equations you can get. So now let us get back to the question. So what is the value of V1 in terms of I1 and I2? So now they have given the polarity. So now we have to follow their polarity only. So now we cannot. So I want V1. So this is at a higher potential, assuming, and this is at a lower potential. So this is at a higher potential. This is at a lower potential because they have given the sign V1 in that way. So now what is the value of V1? Anyone? In terms of I1 and I2. So voltage is, yes,
Sir, 5.
5 watt. Why 5? Okay.
5
So
into
I
1
was
minus
So let me ask you another question. What is the current in this way? In the 5 ohm?
1 minus 1.435.
435. Yes, very good. So this is I1 minus I2, right? Basically. So now what is V1? 5 into I1 minus I2, right?
1 minus 1.435 into 5.
Yes, yes. So into 5 exactly. So now if you calculate that, you will be getting V1 is nothing but minus 2.175 volt. So V1 we got. Similarly, what is V2 now in this polarity, which is V by X? Anyone? What is V2? Value of V2? 5 into I2 minus I4, right? Agree? Or still having some confusion? Hello? V2, value of V2.
minus 13.665.
Yes. So now if I calculate minus 13.665 ampere volt, sorry. So we have calculated the mesh currents and then we have started solving the problem. Yes, agreed. So let us go back and see. So what is the value of V1? Whatever we got, minus 2.175. So within this range it is there. So you will get marks. Similarly, V2 we got minus 13.665. So now let us solve this problem. Find the electric power delivered by the 1 ampere current source in terms of watt. So current source. So say we have a current source like this with a value of I, and the polarity across it is something like this, V. Then the power is nothing but V into I. So now they are asking what is the power delivered by this current source. So we have to get the voltage across this. So what is the voltage? This voltage, anyone? Say this is plus, this is minus, and I call it voltage V1 ampere. What is V1 ampere? In terms of V1 and 10 volts, can you tell? What is V1 ampere? like the voltage across the current source. V1 plus 10, I agree. Yes, Shivam Kumar, V1 plus 10. So the voltage is V1 plus 10 and the current is 1 ampere. So now we'll get power delivered by this 1 ampere is 10 plus V1 into 1. So by this we'll get power by 1 ampere is equals to 7.825 watt. Got it?
V1 plus
Sorry.
10, sir.
Sorry.
How V1 plus 10
Okay.
voltage?
So if you see, I need this voltage with respect to this. So now I can apply KCL. Sorry, let me use a different color. I can use KCL in this way, right? If I go in this way, it is 10 plus V1, right? Right?
But for V1A, it is minus. It comes as minus.
No, why minus? Because the top terminal is at a higher potential. So see, this is at a higher potential, right? So now if I'm going from ground, say initially I'm here. Then if I reach here, I will gain 10 volts potential. So plus 10. So from here to again, if I go here, I'll gain again V1 voltage potential, right? So it is 10 plus V1 because both are at a higher potential. And the bottom one I have considered to be ground. And the top terminal I have considered to be positive.
But for current source, it goes like a negative, no, sir.
So
From plus to minus.
no. See, current source, no, it is not like that. See, these are voltage sources, right? So you cannot say which terminal is positive, which terminal is negative. Again, very good question that you have pointed out. So current source, see, like, let me explain you from voltage source. If this is a voltage source, I can have a current going like this, or I can have a current going like this. It is not always that the voltage source is delivering current. It can also consume current depending upon the circuit. Similarly, current source can have a positive voltage across it, or it can have a negative voltage across it, depending upon whether it is giving power or it is consuming power. So that's why the question will arise whether it is consuming power or whether it is delivering power. But they have asked delivered or supplied or generated. Okay, which means it is delivering power. And uh, when a voltage source generates power, when it is supplying current. Similarly, when does a current source generates power? When it has a positive voltage across it. Then it is generating power. It has a voltage positive and it is generating, giving the current. So in this case, the power is positive. So in both of this case, it is delivering power. Clear? Is this clear? Or any doubts?
So once again,
Okay. So first of all, there is less than a minute, so this meeting might end. Again, we'll come back to uh, clear all the doubts. So let me just open a new page and then write. So I'll consider two cases. So if this meeting can kindly join back, okay? Okay. So this is when they deliver power. So when they have a positive voltage and they are giving current, delivering current, then it is delivering power. So now what is consuming or absorbing power? So let us say consuming power. So when do they consume power? So when they have a positive voltage across it, but they are taking in the current. So they are taking the current. So this is the convention. Praveen, can you please erase? I am not sure. how to disable that. Please kindly erase it. So this is plus minus voltage and it is taking current. Yeah, thanks for erasing. Then this is the current. Then we have plus minus V and current. So the current source is basically in this direction and the voltage is positive. Say like in a simple terms, when do they deliver power? When they have some positive voltage across it and the current, it is going outside it. So it is giving away current. It means it is delivering power. And when it consumes power, when the current is flowing inside and the voltage is positive. So it is taking the current. So let us fix one of the uh, conventions. So let us consider the voltage is positive always. If it is giving away current, it is delivering. If it is taking in the current, it is consuming. So in this case, the voltage is positive and it is giving away current, which means it is delivering power. So that's why they have asked delivered, supplied, or generated. If they are asking consuming power, say something is delivering 10 watts of power, then how much is it consuming? It is consuming minus 10 watt. So this way of questions can also be asked. So if something is delivering, it is not consuming. So if they ask how much it is consuming, you have to put a negative sign, meaning it is delivering. So here it is delivering 7.825 watt and it is consuming minus 7.825 watt. Got it? Whoever has asked.
Then you found voltage across current source by KVL method.
Sorry.
You found current voltage across current source by KVL method in that loop also.
Yes. So in from here to here, I have went and I have found using KVL.
Then it should be consuming power, no, sir. The current source should be consuming.
No. Like you tell me under which two it falls, this or this.
Consuming. Oh, okay.
This like see
Consuming power.
current is going
Yeah.
from bottom to top and polarity. How is it? Negative at the bottom or how is it?
But you took 10 voltage and that V1 in that direction, no, sir.
See,
Anti-clockwise direction.
see, there is no direction that is coming. I am asking, like, see, there are two things. So this or this, okay, either this or this. So in both the cases, so I have just inverted it. So these two are consuming power, the bottom two. This is delivering power. So I will only consider the current source. I consider only the current source. And you tell me whether this is the case or this is the case here in this case. So the rest of the circuit is independent. When I'm asking whether this is consuming or delivering power, I will consider the voltage across it and the current that it is delivering. Okay. So now you tell me whether it falls in this criteria or in this criteria.
Delivering power.
Delivering power. Yes. So now how did I get that voltage? In order to get that voltage, I have applied KVL. Whether I'm going clockwise direction or anti-clockwise, that's a different thing. I can go in clockwise, I can go in anti-clockwise. But usually when I'm going inside a loop, I am following always clockwise. But here, why am I going in anti-clockwise? Because this is my reference and I need this voltage. So in order to go from here to here, I have to go anti-clockwise only. So that's why I have gone anti-clockwise. But I am not going in a loop. I am just going from this terminal to that terminal. So I have seen from this terminal to this terminal, there is an increment in the potential by 10 volts. And again, from this point to this point, there is an increment in the potential by 5 into I1 minus I2. So that's why V1 plus 10 is the voltage that I am considering. And the current is 1 ampere. So power delivered is 7.825. Is that clear?
So that current source both delivers the same current and absorbs the same current.
No. See, whenever we are saying delivering, it is delivering 7.825, meaning it is not consuming. But say in the question, if they ask how much it is consuming, then you have to say minus 7.825. So it is like, see, I have given you 10 rupees. Then you owe me 10 rupees. And how much do I owe you? I owe you minus 10 rupees, meaning I don't owe you money. You owe me. But if I ask you, how much do I owe you? Minus 10 rupees, meaning you owe me 10 rupees. Like that is the convention, right? Got it? Like, say current is flowing from point A to B, and the value is 1 ampere. Say the current is flowing from point A to B, and say the current is 1 ampere. So now I'll ask, how much is the current that is flowing from B to A? How much it is flowing? Minus 1 ampere. Similarly, if something is consuming, something is delivering 7.825 watt, then it is consuming minus 7.825 watt. That's why the sign minus. It is not actually consuming power. We are saying it is consuming negative power, which means it is delivering power. Similarly, current is flowing from
Okay.
B to A minus 1 ampere, meaning current is actually flowing from A to B. So it is just a negation of negation, which means positive. Got it?
So we are taking with respect to the direction of current source, plus and minus.
Yes, yes. So these are the overall things. So you have to see under which condition it is falling, then you can say whether it is delivering or consuming power.
In that question, sir, you took plus above and minus below. With respect to the direction of current source, you have taken us.
No, no, I have not taken this as plus and this as minus. I have considered this as ground and I have calculated this terminal and it happens to be positive, meaning this is what I am getting positive. If you consider this terminal as ground, the top terminal, and if you calculate the bottom value, you will get negative, which means the bottom terminal is at a lower potential.
Then if I change the sign, it should be consuming power.
No, no, no. Okay, okay. So now 10 plus V1 is 7.825, right? So okay. So I'll ask you two things. Say this is 1 ampere, 1 ampere. So say this I have considered to be reference 0 and this is 7.825 volt. And say this I have considered to be ground and this I'm getting minus 7.825. Are they both same?
No, sir.
Why? Okay.
Same, sir, but direction is same.
So you tell me whether the voltage V1 and the voltage V2 are same or not.
Same, sir.
Same, right? So now I can write it something like this, right? Current I plus minus V. So both of them I can write like this, or can't I write like that? Either of the case I can replace it something like this, right? Or still having some confusion. Clear or not clear? So basically the top terminal is at a higher potential and bottom one is at a lower potential.
Okay, sir.
So if I can write it like this, then I'll again go back and see whether it is delivering power or whether it is consuming power. Because my top terminal is at a higher potential, so it falls in this criteria, right?
Yes, sir, but you have assumed positive and negative in that question as well.
No, no, I have not assumed anything. I have assumed this to be ground. So you tell me if this is ground, whether this terminal will be positive or whether it will be negative.
Negative.
This terminal, top terminal,
Positive, positive.
positive. So This is what I have considered, right?
Yes, sir.
So if I consider top terminal to be positive, like this terminal, if I ground it, what will be this bottom terminal, positive or negative?
Positive.
This bottom terminal. If the top is
Negative.
ground, the bottom will be negative, right? Getting or not getting?
Grounded node should be negative, no, sir?
Yes. So if I consider this top terminal to be grounded, then the bottom terminal will be positive or negative.
Positive.
How come? Okay, okay. Or I'll ask you another question. Say this is a voltage source. This is O. This is A. This is 5 volt. So what is VAO and what is VOA?
VAO is 5 volt.
Okay.
sir.
And VOA is
Minus 5 volt.
minus 5 volt. Okay. So in this case, O is kind of ground because we are getting with respect to O. And here we are getting with respect to A because A is kind of ground. So in one case we are getting, if I consider O as a ground, which means this case, then A terminal I am getting positive voltage. In the other case, I am considering A as ground, then the voltage at point O is negative, which is what we are getting here. So if I consider ground at the top, then bottom terminal will be negative. In either of the cases, the top terminal is at a higher potential compared to the bottom terminal. So both of them will fall in this case, and this is what we are getting. Delivering power.
Okay.
Okay. So similarly, there can be questions. They will ask whether 4 amperes is how much power 4 ampere is consuming or delivering, how much power 10 volt is consuming or delivering, and then how much power 8 ohm is consuming or delivering. So similar kind of questions can be asked. So to summarize, we have today discussed mainly about mesh analysis and nodal analysis, and we have solved few problems and saw how to apply the concept that we have learned in solving the problems. And we have also seen that irrespective of the mesh analysis, nodal analysis, we'll get the same answer. But sometimes mesh analysis could be easier to solve and nodal analysis could be easier to solve in some other circuit. So if they mention mesh analysis, you have to solve a mesh analysis. If they have not specified, you have to see which method would be easy and less time consuming, and accordingly you have to solve. So any other queries?
No, sir.
Okay. Okay, then today we can wind this session here. And again, tomorrow, not tomorrow, next week, Monday, 6 to 8, we'll be discussing about week 2. I think it's more of circuit elements like inductor and capacitor and their IV characteristics, everything. So yeah, please go through these videos if you are still not sure, as I'll be uploading it by today night. I'll try to at least. And then if you have any queries, you can mention in the YouTube that comment section. And try to solve as many problems as possible and be confident. If you are not confident, try to see the convention is very important. Plus minus minus plus, they'll matter a lot because the answer will be completely wrong if you mess up one plus or minus thing. And I wish you all the best for your assignment. Consider each week with the same weightage because they'll have same weightage. Don't think that I will do better in the next week and I'll neglect this week. All the concepts are equally important, and each week will have an equal weightage, and the difficulty will slowly increase. So consider each week with the same importance. Okay, and thank you for patience in explaining everything patiently. Yeah, Priscilla, thank you. And how to get this video in recording, sir. So as I have mentioned, I'll be uploading this to my YouTube channel and also uploading these notes to my drive. So let me just give you that link I have mentioned in the top of my comment section. So let us just copy it. Let me copy and then share. So I'm sending you few links. Kindly copy this message because it has multiple links, which using which you can access multiple things like my YouTube channel where you can get these lecture videos, and link to Zoom meeting to enter this meeting and to access the notes. And last year also I have done the same thing. You can also uh, uh, videos and everything you can access. Sir, tell about something about yourself if you want. So I have already mentioned about myself in the beginning. So if you have missed it, I am a fourth year PhD student at Electrical Engineering Department, IIT Kharagpur. I am working under Professor Shantanu Kapat. Yeah, and I am a Prime Minister Research Fellow, and as a part of my TA-ship, teaching assistantship, I have been allotted as a TA, means teaching assistant, for this NPTEL course, network analysis. So I take different NPTEL courses. So I approach the course instructors. For this course, it is Tapas Kumar Bhattacharya and Professor Abhishek Chatterjee. So I'll approach them and I'll tell them that, sir, I want to be a TA for this course. And if they accept, then I'll become the TA. So we approach the professors depending upon my interest of courses. And then once the professor agrees, then we'll contact the NPTEL team saying that we would like to be the TA for this course. And then we prepare ourselves to conduct these sessions, problem solving sessions. So we go through the video lectures and summarize the concept so that I can teach you in a lesser time and summarize everything basically like a quick revision. And then I will also solve problems of the previous assignment so that I can solve them here and make you understand the concepts and help you with solving the problems. So the problems that are given in the previous year will be of the same model that you can expect this year as well. So that's the basic overall idea. So we'll solve previous year problems and understand and gain confidence and see where we are making mistakes and try not to do the same in this current year. Yeah, that's all about me. And if you have any questions about me further, you can always ask in the future in these sessions, and I'm always open to discuss. It need not be technical, or you can ask how to improve yourself, everything. Crystal clear explanation, sir. Thank you so much. We'll attend the class regularly. Yeah. Thanks for attending and thanks for being very interactive. If you are interactive, that will give me interest to teach. If you are not interactive, then it will also be boring for me. Let us keep it as interactive as possible so that I will also be getting benefited by teaching you, and you will also be getting benefited as your doubts will be clear. Okay, then good night, everyone. All the best for your week 1 assignments. See you next week on the Monday, 6 p.m. to 8 p.m. discussing about week 2. Yeah, Jnanandar Singh, I forgot to do this, but next week I'll be explaining this. Yeah, sorry, because today we are running out of time. I'll keep this in mind as this problem will not be coming in assignment, as this is something out of the scope of this course. We can discuss it at any time, and next week I'll be explaining at the beginning. So it is also very simple. Just you can think in the meantime, but as today we are running out of time, I'll do it in the next week. Yeah, sorry for the inconvenience, and thanks for understanding. Okay, then see you guys in the next week. All the best and good night.